3.7b, we're now going to take all of the characteristics of period, amplitude, phase shift, all of that. We're actually going to put together a graph of sine and cosine. So in order to do that, we need to know the table of values for each parent function. Now we went over this when we did 3.7a, day 1. Okay, in that discovery activity, it showed you the parent function for sine and cosine, and you were asked to make a table of values in your work. Okay, but these are the parent functions for sine and cosine. So you'll see that the x values are the same in each function. We go 0 to 2 pi. The y values are what's different. So if you remember, the parent function for sine starts at the origin. So we start at 0, 0, but then cosine starts up at 1. Okay, so they have different starting points, but then they cycle through the same values in order. Okay, so you'll have to know the x values and then the y values for the sine and cosine in order to start your function to make a graph. So we're going to use a table that's very similar to when we were doing transformations. Okay, you put your parent function in the middle and then we work outwards. Okay, on the y side, you're first going to multiply by the a value and then add or subtract d, that's your vertical shift. On the x side, you're going to divide all of these values in the x column. You're going to first divide them by b. So that's what theta over b means. You divide 0, pi over 2, pi, you divide them all by whatever the b value in your equation is. And then your final column on this side is going to be to add or subtract your phase shift. Okay, so this is phase. So in order to do that last column, you're first going to have to calculate your actual C over B. Okay, so this chart is going to make it very, very easy and streamlined to graph your functions. So let's see it in action. So the first thing I suggest doing is just identifying A, B, C, and D. Okay, note what function you're working with. It's a sine, so that we know what y value to start with. Okay, so fill in your x's. It's always 0, pi over 2, pi, 3 pi over 2, oops, 2 pi. That's better. Okay, and sine starts at 0. So 0, 1, 0, negative 1, 0. So my a value is 3. My next column I'm going to multiply by 3. Okay, and then finally D. D is plus 1 in this case. Okay, very, very similar to transformations. The other side, we're going to divide all of our thetas by our B value. So B equals 2. Okay, so we're doing theta divided by 2. So these x values, these are our thetas. So 0 divided by 0 is 0. Pi over 2 divided by 2. Well, how are we really doing that? Multiplying by the reciprocal is the same thing there. So this is pi over 4. Okay, pi divided by 2. Do my work over here. 3 pi over 2 divided by 2. would be 3 pi over 2 times 1/2 times the reciprocal. So it's 3 pi over 4. Okay, and then finally 2 pi divided by 2 is pi. My table's a little messy here. I'm going to get rid of some of this. Okay, now we need to know what our phase shift is in order to add or subtract it. So remember, when we're doing C over B, we take the opposite sign of C from our equation. So we're using pi over 2, a positive. Okay, that's getting divided by our B value, which means I have to multiply by the reciprocal. So my phase shift is a plus pi over 4. So I'm going to add pi over 4 to everything from that previous column. So you'll notice on some of these values that I did not reduce. Okay, and I did that on purpose. So you're going to want a common denominator in this last column so that when you graph your function, each tick mark on your coordinate plane is equally spaced. Okay, so this is the same function. I just moved so I can do the graph now. So I'm going to label pi over 4. All right, and then we're going to plot our points. So pi over 4 comma 1, 2 pi over 4 comma 4, 3 pi over 4 comma 1, 4 pi over 4 negative 2, and 5 pi over 4 comma 1. Okay, remember what the shape of sine looks like, okay, because otherwise these points just kind of look random and you're not sure how to connect them. Okay, so we only graph that one period, okay, and this would be perfectly fine. This is a complete graph for this sine function. Okay, now I just want to take that equation and I just want to talk about the transformations. Okay, so if my amplitude is 3, what transformation does that do to the graph? It's going to vertically stretch by 3. Okay, my period, 2 pi over b, my period is now pi. So remember that the period of the parent function is 2 pi. So we've gone from graphing an entire cycle in a period of 2 pi to now having to do the entire thing in 1 pi. So what did that do to my graph? horizontally compressed it by 1/2. You now had 1/2 the original space in order to graph a period. Okay, the vertical shift was up 1. That was easy. And our phase shift, we know that it was a plus pi over 4. So that was a horizontal shift to the right, pi over 4 units. Okay, so just kind of bringing everything together here with our transformations. Okay, let's try a cosine function now. Okay, so cosine, remember, uses the same x values. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. But the y values start at a different. So 1, 0, -1, 0, 1. Okay, and let's identify A, B, C, and D. Okay, so A is times 1/2 this time. So 0.5, 0. Okay, and my vertical shift is plus 3. All right, that's the easy side. Okay, all right, so theta over b. We're going to be doing theta divided by 3. So remember, those fraction ones, you're probably going to have to multiply by the reciprocal. Okay, so 0 is easy, still 0. Pi over 2 divided by 3 is pi over 2 times 1/3. This guy's easy. 3 pi over 2 divided by 3, 3 pi over 2 times 1/3. Okay, I'm actually going to leave this as 3 pi over 6 for my whole common denominator business. Okay, so then our last column, C over B. So remember, take the opposite sign of your C value from the equation. So negative pi over 2 divided by 3. So my phase shift, I'm really subtracting pi over 6. Okay, so I'm going to subtract pi over 6 from everything in this previous column here. Okay, if you're doing this by hand, subtracting them by hand in your head, you're going to need a common denominator. If you're doing it on the calculator, just don't put the pi in. So you would be subtracting 1/6, essentially, from each of your fractions, and then you put the pi in at the end. Okay, so now we have our 2 outside columns that we're going to use to plot on our graph. All right, so first set up your graph, do your scale. Okay, now I need some 0.5s on this. I guess I'm still going to go by whole numbers. We're just going to have to use in between. All right, So negative pi over 6, 3.5, 0, 3, pi over 6, 2.5, 2 pi over 6, 3, something's not right. Let's check back in our table. Okay. Oh, here we go, this last one. Instead of 5 pi over 6, this should be 3. 3 pi over 6, so sorry. All right, that makes much more sense. Sorry about that. Okay, now, cosine is a little bit harder to find the shape and to get a nice graph, okay? So please don't make this just like a flat parabola. Don't make it a V. Try and follow the curve here of the parent function. Okay. So try and, get a little bit of a curve going here. All right, but I do, I understand with cosine, it's a little bit more difficult. Okay, try not to make it flat though. Okay, and then just let's look at those transformations again. So 1/2 cosine all right, so this was our function. So let's start with amplitude. Okay, so my amplitude is a 1/2. Okay, amplitude of the parent function is 1. So this is a vertical compression by 1/2. Okay, we could do vertical shift. That's an easy one. So this is shifted up 3 units. Okay, and let's talk about the period. So 2 pi over 3. Okay, so what did we do? We went from a period of 2 pi to a period of 2 over 3. So we had 2 pi space to do our cycle in. Okay, and no, that's not what I want to do. Sorry, forget that. Forget that. Okay, so like I said, we went from having 2 pi to do it, and now we have 2 pi over 3. So we'll just say that this is a horizontal compression. Okay, and then what do we have left? Phase shift. So our phase was a negative pi over 6. So we are shifted left pi over 6 units. Okay, so those are our graphing and our transformations. Now the last thing we want to talk about is being able to write an equation, okay, given the amplitude, the vertical shift, all that good stuff. So for this, we're going to have to use our formulas. Okay, so they want us to write a cosine function, and they're first telling me that the amplitude is 2. Well, remember, amplitude, the formula is the absolute value of A. So if they're telling me that the absolute value of A here equals 2, that means that my A value could have either been a positive or a negative 2, because I can put either one of those into the formula and get out this amplitude that's being stated. Okay, so that's my first value. My vertical shift, well, I know that that is the D value. So if it's a vertical shift of 1, D equals 1. Those are the easy parts. Okay, the period. So if the period equals 4 pi, we have to use the formula, which is 2 pi over B. And we're going to set that equal. Okay, we did a little bit of this in the previous section with those graphs, just kind of taking the period and trying to work it backwards. So 4 pi B equals 2 pi. Okay, so B equals 1/2. Okay, and then the phase shift. So phase is C over B. Okay, and they're telling me that that value should be pi over 2. Now, in order to solve this, we have two unknowns, which means we have to use B that we got in the step before. Okay, so this could cause, some problems if you got B incorrect when you solved out the period, because now you're using that B value in the next step. So this is really 2C equals pi over 2. So we could say 4C equals pi, which means that C equals pi over 4. Okay, now we're not done, so we actually have to take all of those values and put them into an equation. All right, so f of theta equals plus or minus 2. They want a cosine. You could say 1/2 theta. You could say theta over 2. Okay, minus pi over 4. Remember, this has to go back into the equation using the opposite sign. And then our phase shift, our vertical shift of plus 1. Okay, so this equation here, this is our final answer.